Hi guys, welcome to our YouTube channel, Teacher Andre Geography. So guys, today we are here to answer the question, why do waters of the Pacific and Atlantic oceans don't mix with each other? Why do waters of Pacific and Atlantic don't mix? So guys, we are here to understand this geographically. So before we go, hit the subscription button, like, share, comment as I give you more tutorials. So guys, we need to understand why has this created a sage among people. Why are many people surprised? What is the cause of this phenomenon? Why does it happen to be like this? Many people say yes, water mixes. Others say no, water does not mix, according to what they say. So we are here to solve the argument geographically. So before we start, guys, you need to understand at least part of this before we reach the cause, or before I explain the cause of why water is appearing like this as you're watching in the video. So guys, the surface of the Pacific Ocean stands about 40 centimeters higher than Atlantic Ocean. So already Pacific Ocean surface is higher than the one of the Atlantic Ocean. And guys, the North Atlantic and the North Pacific stand respectively about 14 to 17 centimeters higher than the South Atlantic and the South Pacific. So the North Atlantic and the North Pacific are relative on a higher surface than the ones in the South. I'm talking about the South Atlantic and the Pacific, as you're seeing on the map on the screen. So guys, the North Atlantic is the warmest and the saltiest. Okay, the North Atlantic, guys, is the warmest and the saltiest. This is a fact, guys. And then the South Atlantic is the coldest and the densest in terms of mass. So guys, the North Pacific has least, or has the lowest average salinity, or the lowest average salt in the water. I'm talking about the North Pacific, guys. It has low salts compared to the North Atlantic. Okay, so guys, the extreme values in the temperatures around the region and the salinity of the North Atlantic are probably related to the formation of the deep waters there that we see. And on this, it's because of these extreme values in temperature and salinity that carry away the upper layer of the cold water to relatively low pressure zones or low pressure areas. So guys, in this we find that the density between Pacific and Atlantic Ocean may partly be a consequence of the west wind drift around Antarctica, and then this is the greatest current of all in the world. So guys, about this, the density between Pacific and Atlantic Ocean, actually it is stated that it is an effect from the west wind drift. I'm trying to make a tutorial about the wind system in the whole world. We shall look at them, their movement. We shall talk about the rotation, everything, what happens, and their effect. So they are saying it's the effect of the west wind around the Antarctica, okay, that forms the greatest current that strikes through all the oceans, that strikes through these two oceans in the world. Okay, so guys, that is a bit brief about what is the similarity and the difference between them. So guys, coming back to our question of today, why do waters of Pacific and Atlantic don't mix with each other? So guys, like, follow, subscribe as we share together. So guys, the meeting place of Atlantic, as it is appearing on the video, and Pacific Oceans looks truly majestic. Okay, and this is by the cause, or this is from the cause or the phenomenon that is called halocline. So guys, all along this line that is separating these two big oceans, it is called halocline. So guys, it is an halocline that is formed, that people are saying as a line or as a barrier that doesn't allow, or like that that doesn't allow this water to mix. Okay, so guys, about this phenomenon of halocline is based on the composition of the oceans. Okay, it is based on the composition of the oceans. So guys, about composition is the making of these substances. Okay, the making of water. Water has composition. It has parts oxygen, hydrogen, and many others that form together to make the soluble water you're seeing, and other compounds such as salts and many others. So the composition is the making of this water you're seeing. So it depends on the composition of the oceans. So when one ocean, maybe a fresh ocean, a ocean with fresh water meets an ocean with salty water, so it's most likely to form an halocline. Okay, an halocline. And then these haloclines, guys, are not only seen between Atlantic Ocean and maybe Pacific. So guys, it is also seen at the meet place of Atlantic and Indian Ocean. Yes, it is also observed that the water shows an halocline, or the difference in color, that one side water is dark, the other side is a bit light, or light green, light blue, something like that. So it's a bit dark and light. That is the difference you already see. So guys, all along the answer was an halocline that is separating these two big oceans. So guys, why does this halocline form to separate these two oceans? So guys, this concerns the degree of salinity. I'm talking about the levels of the salt in the water. Okay, so if one body or if one ocean has more salts than the other, it is more likely to form an halocline, whereby the composition mix or the composition of one ocean will not mix with the other. So guys, the Atlantic Ocean is considered the saltiest and the warmest in the whole world. It is a fact. While the Pacific Ocean has the least or the lowest average salt levels. Okay, and sometimes to some people have referred it to be a freshwater. So they have referred to it to be a freshwater body. So guys, in such a way, when water meets at a point, it's the mineral composition which doesn't mix or which do not mix. Okay, and the extreme values in the temperature and salinity from different oceans also justifies the cast as you're seeing in the video. So it is about this, okay, about the composition that which is not allowing to mix. So it creates a camouflage into our eyes, and we see that this water is not mixing, and of which it is true. When you see different water bodies and they make a boundary that this side may be Indian Ocean, this side Atlantic, or this side is Atlantic and this side is Pacific. So guys, if you want to see this clear, just make a simple experiment at home. You can have two glasses, and one glass you can put fresh water, the other glass you can put water, then you add salt, then try to stir, then allow it to settle for at least 2 to 3 minutes. From the glass direct, guys, you will be able to see the barrier line, or one line, which we are calling a halocline in this tutorial today. So you will see one line in the glass that is separating the fresh water from the salty water. That line will be formed as you're watching in the video, or as you're doing some small experiment at home. You will see this line forming. Okay, so this is what we are trying to talk about. I've not said that the taste of water will change. No, the whole water will become salty, but I'm talking about the visual impression, what you will see from the glass. You will be able to see that the water has separated, and the one you see at the top will be the fresh water, and the one you see down will be the salty water. So that is a simple assignment, guys, of which each of you can try. So guys, haloclines appear when the water in the sea or the ocean is at least 5 times more than the other sea or from the other ocean. So if these two oceans meet and then one ocean is 5 times haloclines or high degree of salt lines than the other, it's most likely for us to experience an alkaline, or like a boundary that is separating two borders. So guys, also temperatures can lead to this, as one ocean may be warmer. For example guys, Atlantic has warmer water than Pacific. This can also lead to a formation of a barrier, since warm water may not mix with cold water, especially in these water bodies. It is also possible to form an alkaline. So guys, also it's not only in these regions that we are experiencing this, but when you do geographical studies, or when you move to the field around the world, you will be able to find many other seas worldwide that are facing haloclines. So you will still observe these many water bodies, okay, as you make the tour, but it still stands that it's the mineral composition of these water bodies or the oceans or the seas that doesn't mix, or that is not mixing. But visually, when you see by our eyes, we shall see them as if they are creating a boundary, that maybe one side it's a different water body and the other side it's a different body. So we also have a typical example around here. So for example, we have Mediterranean Sea and Atlantic Ocean. Also, this water is evident that it is not mixing for the people who have tried to be there. So people who have seen this gorge separating Spain, Europe and Morocco from Africa, there is one water channel. So people have observed this water also not mixing. The water formed an halocline, or some people can call it a front. Like you see that water is not mixing at all, partly because Mediterranean has fresh water and then Atlantic has high degree of salinity, has a lot of salt in its water. So thank you guys for following, liking and everything. For any questions, hit the comment section, suggestion, ideas. I will be grateful hearing from you. You can DM my Gmail at brandyandi52@gmail.com as you're watching on the screen. Thanks guys for liking, following, subscription to our YouTube channel. See you in my next tutorial.